Welcome to Lesson 6, Characteristics of Electricity, the Cost of Power, and Calculating Your Power Bill. Batteries are often called cells in science. That's the nerd way us physics people call batteries. We call them cells. The first batteries were made of two metals sitting in solutions that contain those metals. So a copper rod sitting in a solution that had copper ions dissolved in it, and a zinc rod sitting in a solution that had zinc ions dissolved in it. It kind of looks like this, and this is something you'll build in Chem 30. We'll make our own cells in class and measure the voltage. It was noticed that if we connect the metal rods with the wire would have electricity flowing through it. This was accomplished by Alessandro Volta in 1800. In 1839, William Grove made the first fuel cell. This is a special battery that combines oxygen and hydrogen to make water and electricity. Over the years, with much experimentation, the battery has changed a lot. The early batteries were all wet cells. The name wet cell was used to describe these batteries because they had a solution, often an acid inside of them. We still use a lot of wet cells today, like the car battery. The first rechargeable batteries were developed in 1859 by Gaston Plante. The battery he developed is very similar to that car battery we still use. And this is a picture of that battery he had produced. The photograph comes from the Smithsonian in Washington, D.C. In 1881, the first dry cell batteries were produced. These use a gel or a pasty low moisture electrolyte. The advantage to these batteries is that if they break open, the spillage is easy to contain. They still contain the same harmful elements, but it's easier to clean up. And that's why when we do science fair projects, you're supposed to be using dry cell batteries to protect yourself and anyone who may be looking at your project. The first solar battery was not developed until 1954, and this is a replica of what the first solar battery looked like. Now imagine your calculators all have solar panels on them now. Imagine having to put something like this on your desk and angle it towards the light in the room so that your calculator would run. Today there's a lot of research going into the fuel cell that was first discovered in 1839. Many people consider this to be the future of power generation, since the only byproduct is water, and water is not harmful to the environment. Some of the terms that we need to know in this unit are electrolyte, wet cell, and dry cell. So an electrolyte is a fluid that can conduct electricity, just like when we added salt to water and saw that it could conduct electricity and we were able to turn Mr. Wall's light bulb on. A wet cell is a battery that contains a liquid electrolyte. A dry cell is a battery that contains a gel or pasty low moisture electrolyte. Now the batteries that you typically use in your house, AA's or AAA's, are wet cells. And you can tell that when a battery has sat inside of a device too long, it may have broken open and you can see the residue had leaked out and potentially could wreck your device that battery was in. Are batteries a good source of energy? What do you think? Let's check it out. The materials that has to go into making a battery has to be collected. The metals need to be mined and refined. Both steps use a lot of energy and release a lot of harmful chemicals into the environment. At one time when I was taking one of my upper level chemistry courses in university, they said for every kilogram of product produced, there are 3 kilograms of waste produced in the mining industry. So obviously, if we want to be good to our environment, we want to reduce the amount that we're taking out. Not that we can stop mining completely, but if we reduce the amount we're consuming, that means we have to mine and refine less materials, which is better for our environment. Again, the material that has to go into making batteries has to be collected, and oil needs to be refined to make packaging and to make the casings for the battery. This also requires a lot of energy and releases a lot of harmful chemicals into the environment. Again, necessary for the production of batteries, which are necessary for us to function. But if we're able to reduce the amount that we're consuming, then we're reducing the amount of pollution that needs to be created. Batteries have to be manufactured and packaged. So once they get all those materials together, they have to go to a facility that will produce the batteries. Of course, they all need power in order to build the batteries, so the more they build, the more energy they consume. And again, the more we consume, the more they have to produce. And that wrapping goes into the landfill, and about 2/3 of the batteries eventually wind up in the trash too. Battery recycling started in 1912. Most recent stats suggest that Canadians recycle less than 6% of the batteries they consume. 20 to 40% of phone batteries and other consumer-related batteries are recycled. But if they do wind up in the landfill, and there is a charge inside that battery still, it could break open and it could start a fire. Now, all those batteries aren't produced in our local town. That means they have to be shipped in large containers, which then they take those containers full of batteries and put them on semi trucks, and then they have to distribute them throughout the country, which then go to smaller distribution centers that send them to stores. And then eventually we go and pick them up. So there's a lot of gas that's involved in transporting those batteries from where they're produced, usually overseas, to our local store. And then there's the issue of those toxic metals that seldom get recycled. Batteries comprise of many toxic chemicals and elements such as lead, mercury, and cadmium. Because batteries have so many dangerous chemicals, North Americans often export them to third world countries to be dismantled, seldom done in ways that address environmental concerns. Just recently, it was released that many of the batteries that are consumed in North America end up going to Mexico to be dismantled because Mexico has lower environmental standards than we find in the United States. If not properly disposed of, these elements enter the environment and accumulate over generations, causing things like birth defects, disease, and poisoning. All batteries eventually break open, releasing the chemicals inside. Rainwater washes these chemicals into fields and streams where they are picked up by all sorts of animals. Eventually, we pick up these chemicals too by eating the animals like deer and cows that have drank the water or fish that live in the water. And then there is the cost associated with battery-powered energy. It costs $68 to $400 per kilowatt hour. Whereas if you plug it into the wall, the electricity from the wall costs us somewhere between 7 to 19 cents per kilowatt hour, according to the Energy Information Administration. If you don't have the plug-in option, however, rechargeable batteries are worth considering. Right now, demand for rechargeable batteries only account for 1 in every 5 batteries purchased. It was getting better at one time, but rechargeable batteries have started to slip in the market because now you can buy those giant packs of 24, 36 batteries for a very nominal fee. So now disposable batteries have become much more popular again. Now we're going to talk about that power bill. The power bill goes up and down with the seasons. Some people go on equalized payments. This means that the power company will estimate how much power you will use over the year and charges you 1/12 of that total every month. There are many reasons why people use more power in certain seasons. And one of the main reasons people like to go on equalized payments is because it makes it easier to budget. If you know how much you're going to be charged each month, then you know what's coming out of your account. And it gives you a better idea of how much will be left in your account at the end of each month. There are many things in the wintertime that could cause your power bill to be higher than normal. Stuff like having your Christmas lights on, or your house lights are on more because it's a darker time of the year. Or you're running space heaters, and space heaters draw a lot of electricity. And your TV is on more, and probably Blu-ray players, your Netflix receiver, your gaming consoles, because a lot of people spend more time indoors when it gets really cold. You can pause and fill in your booklet now. There are things in the summer that cause your power bill to go up as well. If you have a pool, then it's going to cause your power bill to go up quite a bit because it requires a lot of energy to heat your pool. Air conditioning also uses a lot of electricity. People typically have more fans on to try to keep cool, and we're doing more yard maintenance, so the electric yard tools are probably getting used a lot more often. You can pause now and fill in your booklet. Now, to determine how much you have to pay SAS power, the amount of power we used is based on the amount of current the item draws, how long the item is running, and what the cost of power is. That makes complete sense, right? Because how much do I owe? Well, it depends on how much power the item draws. If it's a big fan, it's going to cost me more than if I have a little fan. A big TV will cost me more than running a tiny TV. Of course, the time it's on for, the longer I run something for, the more I'm going to owe. And then the last one is the rate. That is what SAS Power has decided they are going to charge me per kilowatt hour. The higher their rate, the more I'm going to owe. The lower their rate, the less I'm going to owe. So we have to figure out what SAS Power's rate currently is. This is from the SAS Power website. For this exercise, we are going to assume that everybody lives in Lumsden. So we're going to use the rate for town, village, and urban resort. The basic monthly charge is $22.79. So if I leave for a few months and don't have any electricity usage in my house, I will still get charged $22.79. That is a charge to be attached to the grid, and that goes into maintenance of lines. So if the wind blows and a tree branch comes down and knocks out power, that helps cover the cost of maintaining the lines that are running to my house. This is what we're going to be using. This is the charge on top of the basic monthly charge, and this says that I get charged 14.228 cents per kilowatt hour. I'm going to write that into my booklet. SAS Power's current rate is 14.228 cents per kilowatt hour. If you do not have your booklet with you, you will have to pause now and draw this chart out before you continue. If you do have your booklet, we will start to fill this out. I want you to always run each number through your calculator twice to make sure that it is correct and you haven't accidentally hit the wrong button. I would start by looking at the watts. Now I'm getting charged in kilowatt hours, so that means my wattage has to be in kilowatts. So to convert from watts to kilowatts, you need to divide the number of watts by 1,000, just like I need to divide the number of meters by 1,000 to get kilometers. It's just a metric prefix. Make this note, kilowatts equals watts divided by 1,000. So 2,000 watts divided by 1,000 gives me 2 kilowatts. 110 watts divided by 1,000 gives me 0.11 kilowatts. You may pause now and fill in the rest of that chart if you wish down the wattage side, or you can continue on with me now. Again, the rate is in kilowatt hours, so that means my time has to be in hours. But you can see the first one says 18 minutes. Now there are 60 minutes inside of an hour. So to convert from minutes to hours, you need to divide the number of minutes by 60. So I made this note, hours equals minutes divided by 60. So 18 divided by 60 is 0.3. But this stays as 3.5 because I'm already in hours and there's no need to convert. Just like if the wattage was already in kilowatts, I wouldn't divide by 1,000 because it's already in kilowatts. So to figure out how much I owe for my hair dryer, I have to take the wattage, which is 2 kilowatts, multiply it by the time, which is 0.3 hours, and multiply it by the rate, which is 14.228 cents. And that means running my hair dryer for 18 minutes cost me roughly 8.5 cents. So I'll write that into my amount owing column. My light bulbs, well, I have 7 light bulbs, so I'm going to take 7. I'm going to multiply it by the wattage of a single light bulb, which is 0.11 kilowatts. I'm going to multiply it by how long each one of those lights were on, which is 3.5 hours. And again, multiply it by the rate, which is 14.228 cents. So I owe 38.3 cents to have 7 light bulbs on for 3.5 hours. Now, after you tally up all these numbers, you need to get your total and round to the nearest penny. Complete the rest of the chart now. Here are the answers. to check your work.